Okay. Okay. So today I try to finish it tonight. 44 page. So some part I skip for basic of sensor. So I focus on the circuitry and also calculation of sensor. So design introduction, design and task requirement, actuation scheme, sensor and sensor fusion, position sensor, sensing for sensing. Okay. Okay, robot system consists of 4 elements, which is manipulator. So we focus on robotic arm. So manipulator is a robotic arm, including internal sensor and actuator. End effector or tool. End effector is a gripper or welding tip, drill. So that one is end effector or tooling. External sensor and end effector. So you have internal sensor, maybe you have sensor to check your current, and then you want to check your voltage, and then maybe you want to check position, your robotic arm position, encoder, variable, something like variable resistor to measure your position also. External sensor, maybe you put your robotic arm with a force sensor, or touch sensor, textile sensor. So that one is external, to send external surrounding. And then you have also controller. So controller, you have many type of controller. You have PC based, you have microcontroller based controller. Then because this one I make it faster. Normal degree of freedom, this is same like workspace lah. This is workspace. Okay, performance of robot based on load capacity, speed, repeatability, and accuracy. So this is when we talk about performance. So we talking about for robotic, what is the load capacity the robot can work. Robot can pick up load capacity, the heaviest of material that robot can pick up or manipulate. Then speed, what is the speed of robotic arm can move or can process, the speed of robotic arm. And then repeatability and accuracy. This is very important because you need a robot that good in accuracy and good in repeatability. Okay, actuator, actuation of robot joint. At robot joint, say common actuator, hydraulic cylinder, pneumatic cylinder, and then electrical motor, DC, AC, or stepper motor. So this is common actuator. If you think about very strong, so normally we use hydraulic, but hydraulic, the accuracy of hydraulic is not accurate as electrical motor for the actuator. Pneumatic cylinder, a very high speed, but now stepper motor or DC motor also very high speed than pneumatic, but it's not depend to the cylinder or the component that we use. But faster now is more on the DC or AC motor lah, stepper motor. Pneumatic, they are more on fast and strong. Electric motor is accurate. Now, because you have gearing system, everything, so DC motor also is quite strong. It's quite strong compared to the pneumatic. as you seen in KUKA robot, adapt robot, that one all they use stepper motor or DC. Some they use AC motor. It's very strong, and they use for pick and place a very big equipment. So now electric motor, so they are combination high accuracy and high torque. So this is how internal of the motor look like. This is DC motor. This is stepper motor. So DC you have 2 pole. Stepper you have many pole inside. That's why you can move. They call stepper motor, step by step. So if you think about high accuracy, but you don't want to use sensor or encoder to measure position, so you can use stepper motor, because stepper motor, their moving is step by step, so it's not exceeding the position that you control. So if you say move 10 steps, so robot motor will move 10 steps. Compared to DC motor, if you move using, although you use PWM to move the motor, to turn the motor, PWM, you use the concept same as stepper motor, you use pulse width modulation, but DC motor will have a problem like a drift lah. So if you say stop, so motor still have a drift error, so dia masih terlajak. So that one is DC motor. That's why DC motor you need to couple with encoder to make sure the position is accurate. Stepper motor, you just need home sensor. If you put encoder, yes, you can put encoder to measure, but normally stepper motor is already accurate. So you just need reset sensor or home sensor to reset the position. Current issue, actuator produce high speed and low torque, need speed reduction system. Normally, this is normal lah. Actuator produce high speed when you use a DC motor. So you produce, when you put the power, so the turning is very high speed, but low torque. So you need a reduction system or gearing system to increase the torque. So when you use a gearing system, you are lower the speed and increase the torque of the motor. If you want a very high speed and high torque, so the price of the motor is higher. So they also have higher speed and higher torque, but the price of the motor is higher. Normal, the lower cost DC motor, you need to select whether you want high speed, low torque, or you want low torque or high speed and high speed. So it's option normal for lower price of DC motor. If you want both high speed and high torque, so normally the name of the motor is like Vexstar motor, or the other one is what, Planetary. So the price is higher, high torque and high speed. Actuator are heavy. So for example, hydraulic is heavy equipment, heavy actuator. So everything is heavy. Pneumatic require compressor, but now compressor, they have a small compressor they use for skeleton robot. So now they can develop a small compressor. But before this, compressor is a big size lah, bigger size. Motor does not have high power to weight ratio. This is motor lah. The problem, motor does not have high power to weight ratio. So we need a gearing system lah. need transmission system. So if you motor or you use hydraulic or any actuator, so you need transmission system. You need maybe linear, what we call it, linear drive. You need same like a ball screw, ball screw. So that one is heavy. It's a metal component. This is gearing system. Example, direct drive actuation is preferred to simplicity and controllability. However, inertia of manipulator will increase. Trade-off between control and inertia, speed reduction and transmission system, gear, cable, belt, flexible band, roller change, lead screw. This is the type of speed reduction system, speed reduction system. Reduce the speed and increase the torque. Okay, sensor and function. Robot must gather information from the environment, obstacle, for example. So this is robot must gather information from their environment. So this external sensor. Robot need to gather information about itself. So for example, status of motion, something like encoder, so link and join. So we need to get the information internal of robot. So this is external of robot. Environment, this is internal robot. Normally this one we use encoder. For obstacle, maybe we use ultrasonic, we use camera, we use laser, or maybe touch sensor, force sensor. So they want to measure the environment. For internal, we have current sensor, voltage sensor, we have encoder. So they want to measure internal of the robot. So major function of sensor in robot. So status sensor, status is example for in case of like this, to measure the voltage, current inside the robot. Environment is for external. Quality control sensor, maybe you put a pH sensor, maybe you put gas sensor, quality control. Maybe you put gauge at the end effector, you put gauge. If you work in the industry, they use a robot to measure the size of the product. Say they use a robot arm, and then they have a gauge at the end too. So the gauge will measure the height of the product or the shape of the product to make sure the product meet the requirement, the size. Safety sensor is something like a laser. They put as a cage of the robot for safety. Or maybe they use a basic sensor, something like limit switch at the cage to make sure the operator didn't open the gate or the cage during the robot operation. And then work cell control sensor. So work cell control sensor, they have many sensors. They have combination of all this. So sensor performance, this some maybe has been explained by Prof. Abu, range and span. So range, that means your sensor range, maybe based on distance, based on angle, your open angle of the sensor detection, error and accuracy, sensitivity. So your sensor accuracy, resolution. So resolution for accuracy, example laser, maybe their measurement in millimeter. So that one is accuracy. And also resolution, if you use a camera as a sensor, so your camera have a resolution, maybe 1 megapixel, 2 megapixel. so resolution. And also laser, they call resolution also, sorry, resolution. So your resolution mean what is your distant measurement, the smaller distant measurement, for example, in millimeter or in centimeter. So that one also called resolution. Response time is what is the speed of response of your sensor. So for example, if you use a laser, so you detect you measure something, your object, what is the reflecting or response time that the sensor can get the information. So the distance of the object. So what is the faster robot can get the information. Hysteresis, linearity. Linearity means that something like this. So sensor or any component, they are non-linear. They are non-linear. So for example, if you buy any sensor, so actually your reading of the sensor is something like this. It's curve. Curve that means unlinear, not linear. So the manufacturer, they try to change this non-linear information of the sensor to linear. So we need a linear sensor. So normally they put some controller, a small controller at the sensor to ensure that the data that the sensor receive non-linear change to linear. So this is the linear. Linears mean that if you set your sensor reading, for example, you buy a variable resistor that can turn. That means you can turn your resistor from 1 ohm to 100 ohm, for example. So actually your reading is non-linear. It's curved, something like this. So maybe you turn little bit, your reading already high. You turn little bit, your reading become higher. And then at the last value, so your reading is correct. So this is non-linear. So manufacturer has studied this. They improve the quality. Maybe they change the material of the resistor. So they get a good reading. So this one we call linear. So we need a linear sensor because if we get a linear sensor reading, so we can control. So because we get accurate reading, so we get accurate reading, so we can control correctly. Yeah. For example, if the value is the resistor give 10 ohm, it's really 10 ohm, not curve. It's not curve. It's not nonlinear. So it's linear, then we can control. It's a good control. We can give a good response to your actuator. Repeatability compared to accuracy. Accurate, that means your reading that your sensor, you get the reading is accurate. So if the temperature, for example, temperature sensor measure 10 degree is really 10 degree. So that one is accurate. Repeatability, that means if you off the sensor, then you on back your sensor, so you still get 10 degree. So that means your sensor repeatability is good. High repeatability. If you off the sensor and then you turn on back, so your sensor give 9 degree. And then you off the sensor and then you turn on back, your sensor give 11 degree. So it's up and down. So when up and down, that means your repeatability is low. But if you turn on continuous, so your sensor give 10 degree. You on for 1 hour, so your sensor gives 10 degrees. That one is accurate. Accurate. But if you on and off, so your reading give unstable reading. So that one is lower repeatability. If you off and on, so your reading still giving 10 degrees Celsius. So that means your sensor is good repeatability. Stability, output impedance is your sensor got high output impedance or low output impedance. So this one you will use in what they call it, output impedance high resistance at your sensor output. They have some application on that. So one sensor usually not enough. Okay, this is sensor fusion. Sensor fusion means that you have many sensors and then you make decision based on many sensor detection. So you can choose which sensor you want to use. One sensor is usually not enough, noisy and limited accuracy, unreliable and limited point of view. So for example, if you have only one sensor, so it's high possibility to be make a wrong decision. You can make a wrong decision. Robot will make a wrong decision. So you need more than one sensor. Concept of sensor fusion. Okay. Normally for a robot application, their requirement for sensor is 3 types of sensor. One is an optical and sensor using light, maybe infrared, maybe vision system, or maybe laser. And the other one they request is something like sonar sensor, sound sensor, for example, sonar, something like that. And then you have textile sensor or touch sensor. So because optical, you have disadvantage on lighting or on mirror. So they have failure, sensor failure on that situation. Once you use a laser, you cannot scan a mirror or vision system also, you cannot scan a mirror. You will have a confusion problem because you see more image in the mirror. Laser also, when you use your laser sensor on the mirror, laser also will fail because you have reflection problem. So that's why they want a sonar sensor to be applied in the robot, because sonar is not fail on the mirror and also on the glass condition. So sonar will detect every obstacle except the material that absorb sound. So that one sonar will fail lah. But normally sonar will detect all the obstacle. Then the third one, they want textile sensor or touch sensor on the robot, because if both sensor, sonar and obstacle or lighting sensor fail, so you have a last safety sensor, which is touch sensor or textile sensor. So that's means if both sensor fail, so you have a last sensor to stop the robot. So normally for this one, they apply for mobile robot. Mobile robot, because they want to release the robot in production. So they want the robot to be safe for the worker or in the environment, working environment. So they need 3 types of sensor before. You cannot just use one type of sensor because you have a failure condition. You will have high failure condition. And then concept of sensor fusion in robotic. Sensor fusion combine reading from several sensors to produce data structure. So for example, you have laser light sensor, you have sonar sound sensor, and then you have textile sensor. So you have all these several sensor data. From that several sensor, you will make decision based on several sensors, not only one sensor. So that means if your robot move, for example, mobile robot, move in the working environment, so they will check, the robot will scan using a laser, and then it's clear, so it's not, the robot still not make decision yet, and then a robot will scan with sonar. Okay, scan with sonar, compare. That means laser is safe, and then sonar also safe. That means the working, maybe the working path, we call what, corridor is clear. No people in the front of the robot. So both sensor pass, and then the robot will check the last sensor is tactile sensor or touch sensor. So if nobody touch the body of the robot, so then the robot move forward or move backward or turn or do anything the robot want to do lah. So it's not depend on one sensor. So that one is we call robot fusion. Something like this. So you have many sensor, and then combine the sensor, record all the information from the sensor, and then interpret. So robot make a decision. So the robot not make decision based on one sensor. This one we call fusion, sensor fusion. And then this one, sensor go to microcontroller. You have control equation, maybe sensor fusion equation, and then instruct your actuator move the actuator. And then sensor will measure again. Maybe this is encoder sensor, or maybe this is laser sensor. Then go back to your controller. Oh, 9 o'clock already. So how many students join? I hope the number is increased. 79, correct? Any question, Anak, until this? So this is theory, not calculation yet. Okay, this is important. So make sure you understand this type of sensor, encoder. I'm not sure it's coming in your exam or not, but for your examination this semester should be different little bit with last year. Should be different little bit. In sensor topic, if you see last semester, shows calculation in type A maybe. So maybe that equation, that calculation is not coming for this semester. So you need to study on different calculation. You don't have many calculation in this sensor. You only have 2 type of calculation. So if you see last year, you already see that calculation. So you study the other one. Okay, I didn't turn on the video. Okay, I just turn on for a few minutes. Just for evidence. Record. I'm going to take about 10 minutes and then close back. So I don't have enough space to keep the video. The video take about more than, if 1 hour is about 1 gig already. Everybody still online?
Yeah, betul.
Okay.
Yes, betul, yes.
Oh, yeah.
Tengah fokus.
Oh, no. Okay. So we go back to our slide. Okay, this is encoder. So encoder. Okay. Okay, smaller a little bit. Okay. The position sensing. We call position sensing. What is position sensing? There's this is one example of position sensing. We call encoder. So there are many type encoder. We have optical encoder. We have position sensing, magnetic, we have optical, we have magnetic, we have potentiometer. So all that to measure position of the rotary actuator. This is for rotary actuator. So we use optical encoder. Each joint require position sensing to keep track of its motion. Ideally, the location of position sensor is on the actuator shaft for simplicity and controllability. This type of one type of optical encoder. So some is rotary, some is straight. So rotary normally they put at your servo motor or at your DC motor to measure your rotary rotation position. This is example. So you have transmitter here. This is transmitter circuit. This is receiver circuit. So you have photo transistor here. So you have LED, for example. This is LED. So this is input logic signal. So you give a signal here. So sorry, this is 5 volt. Go through R1. So what is the function of R1? R1 is to reduce the current. Because 5 volt, the current is high. So you need a load to prevent the LED burn. So you put R1. Normally R1 we put 220 ohm or 330 ohm. The maximum we put is 1 kilo ohm, 1000. So R1. Normally for LED you put 220 ohm or 330 ohm. So to prevent the LED burn. So when your voltage go through this LED, so LED will give a light. This is a lens to focus the light, because maybe your strip is very small. So this is a dark part. This is maybe transparent part. This is dark. This is transparent, or maybe this is block. This is window. Some they call block. Some they call dark part. So, this we call rotating this. That's me rotation. So ada microphone on. So you want to focus the light go into narrow window or transparent window. So if this transistor detect the light, so the current can go through ground. When the current go to ground, so the voltage here becomes 0. If no light at the phototransistor, that means the voltage 5 volt will go to your plus port. So this positive plus will receive 5 volt. So if the light detected by this phototransistor, so the current will go through ground. So there are 0 volt at this point. So 0 volt. This is inverter lah. Anode. Anode mean if this positive got 0, this one will change 0 to 1. So 0 change to 1 because this is not gate. So 0 become 1. If 1 change to 0, depend to the skid. So some they want active high, some they want active low. This is changing active high or active low. So if you put this AND gate, AND node, so you will get active high. So when this go to 0, that means detect something. So this voltage change to 0. 0, the output is 1. So active high. Active high. Any question on this figure? Simple je kan? Ni buffer lah. Buffer. Buffer ni, the function is to prevent noise. To prevent noise. So if you have, maybe because some component, they have error. That means they have maybe after you go through R2. So this one is not 5 volt because it's already reduced. So maybe you have here about less than 5 volt. Why we put this? Because we want to prevent short circuit. We're going to prevent short circuit. For example, if we don't have resistor R2, and then the light detected by phototransistor, so the current, full current will go through positive to negative. Positive to negative, that means short circuit. So your circuit will burn. That's why we put R2. Same go to this part. So LED doesn't draw much current, 0.7 volt or 0.3 volt only. So if you don't put the resistor, so full current will go through LED. First, LED will burn. So you don't have short circuit, but you have open circuit because your LED burn. This one, because phototransistor can pass, can pass a big current, so you will have short circuit. You will have short circuit. This we call incremental encoder, optical encoder. Optical means lighting. Optical means lighting. Because you have also magnetic encoder, this optical. When you say optical, optical means you use infrared or you use LED sensor to detect the position, the encoder. This is rotary encoder. So this is we call optical rotary encoder. They have a linear encoder. They have rotary encoder. So incremental means that we can count increment. We can count 1, 1, 1, 1. So you plus 1 plus 1 plus 1 plus 1. So incremental. If you have one sensor, you only can count whether increase or decrease. Increase or decrease. So that one depend on your programming. If you have two sensors, you can measure direction. You can measure direction. In generate pulse proportional to the rotation speed of shaft, direction can also be indicated with a two-phase encoder. Phase encoder. Okay. So if you have two sensor, you can measure direction. How you measure the direction? Because one sensor you put at the window, the white color window encoder, the white color encoder, or maybe transparent, and the other one you set at the block or the black. This one window, this is a block. The black color is a block, so current cannot, light cannot go through. So when you position like that, so you can measure sensor A receive the current, sensor B not receive the current. So for example, sensor A going up, that means detect a light maybe, or maybe not detect the light, depend to the position of your sensor. While sensor B not detect the light. So if you turn the other way, so you can see that A not detect, B detect. So they are vice versa. So that vice versa indicate that the direction whether clockwise or counterclockwise. So if you have two channel, or 2 sensor, so you can identify the direction of the rotation, whether clockwise or counterclockwise. For example, sensor one, state 1, sensor A high, sensor B low. So that means one detect the window, one detect block. And then sensor high, sensor 2, state 2, sensor A high, sensor B high. That means both detect block. And then state 3, vice versa, sensor A low, sensor B high, and then low. So if you see the sequence like this, so you can make a conclusion that robot rotate clockwise. If you turn the other way, you can see that low, and then your sequence here will be the other way. So if the other way, that means maybe counterclockwise. So if you have 2 sensors, then you can make decision. You can detect whether the motor rotate clockwise or counterclockwise. If you have 1 sensor, then you only can count. So for example, you have 200 slot or 200 window. That means you can count 1.5 degree. So because why? Because one rotation is 360 degree. This is important. Maybe the question asks, what is the resolution of this sensor? So resolution of this sensor, if you have this 200 window or 200 slot, so one rotation is 360 degree. So you divide 360 degree divide by 200 slot. So you get 1.5 degree. 1.5 degree is resolution for this encoder. We call resolution. So what is your sensor accuracy? Your sensor accuracy is 1.5 degree. Or your resolution. What is your resolution? Your sensor resolution? Your sensor resolution is 1.5 degree. Clear ni? One rotation is 360 degree. Your encoder have 200 slot. That means your resolution equal to 360 degree divided by 200. So you can, your answer is your slot or your resolution, each slot is 1.5 degree. Each slot is 1.5 degree. So, or your resolution of sensor is 1.5 degree. So that is the accuracy you can control your DC motor. So because your sensor will detect the position of your DC motor. So your resolution of, you can control also 1.5 degree. If you want a very higher resolution, then you need to buy more expensive encoder. So more expensive encoder, they can make a very small slot, maybe more than 1,000 or maybe more than 3,600. So you will get a very small resolution, maybe 0.01 degree or 0.1 degree resolution encoder. So you get higher accuracy. You can control. So ni motor. This is motor. This is, you put encoder. Normally motor that has encoder, they have shaft forward and backward lah. So you can see that the back side they put encoder, and the front side of the motor, the shaft at the front side, you connect to your tire or you connect to your arm, robotic arm. So this side you connect to your robotic arm. The back side you connect to your encoder circuit. So if you purchase your DC motor, if you want to use encoder or you don't want to use encoder because the price is almost similar, better you purchase with encoder, because now they put a magnetic encoder at the back of the DC motor, and the price is quite similar. Maybe a little bit higher than the other one. So better you buy the motor that with the encoder, because normally when you use DC motor, you need to measure your position. You need to measure your position because DC motor is not accurate. Without encoder is not accurate. So this is incremental encoder. You can see that you only have slot. The difference is if you have one sensor, you only can measure, you can count up and down, but you didn't know the direction of rotation of motor. And then if you put two sensors, you can measure, you can count the position, and also you can know the direction of rotation, whether clockwise or counterclockwise. This is another sensor we call absolute optical. Still use a light optical, absolute optical encoder. The difference with this incremental encoder is with this sensor, if you turn off your robot, so you didn't know your position, because this encoder is not absolute. It doesn't have spatial mark to identify your robotic or your joint arm position. You didn't know. After you turn off your robot, when you turn on back, so your reading will be 0. So you didn't know. Your counter also will be 0. Unless you have memory, backup memory. But that one also is not accurate, because if you turn off your power, your arm will be, you doesn't have power, so your position already out. So you didn't know your exact position. But if you use absolute encoder, whether you turn off your robot or you turn on your robot will know your position, because your encoder has digital value. Absolute position encoder are made using pattern disk. Pattern, this is example lah. This example, you have 8 we call 8 sector. You have 8 sector. So this example lah. This is very low quality, or not low quality, low resolution lah. Low resolution. Because one resolution is about 0 to 45 degree. Low resolution sensor lah. This one cheapest one lah. So if you use in the machinery or in the industry, they will use a very high resolution. So you have maybe 100 or maybe 1,000 sector. 100 or 1,000 sector. It's very small sector. So you can identify maybe 0.1 degree or 1 degree, something like that. So very small sector. That one we call high resolution. How this sensor, absolute encoder, can detect the position? Okay. The concept is similar to this incremental encoder, but for your absolute encoder, you have, for example, this one you have 4 track. You have 4 track. 1, 2, 3. 3 track. 1, 2, 3. So each track have sensor. So you have 1, 2, 3 sensor. And then you have 8 sector. 8 sector means that you have 8 position. So for example, if your sensor here 1, 2, 3 detect 0, 0, 0 or off, that means your position is at 0 to 45 degree. This is 0 to 45. So this is 0 degree, this is 45 degree. So if your sensor detect here 0, 0, 0, So your position of robotic arm is within this sector, 0 to 45. But because your sensor is low resolution, it's not so good. So your resolution is 0 to 45. Ni sensor murah, cheaper sensor. So kalau you buy a expensive sensor or high resolution, so your section here will be 0 to 1 degree or maybe 0.2, 0.5 degree. It's very high resolution lah. This is the concept how absolute encoder detect its position. So although you off your, for example here, 0, 0, 1 or off, on. So off, on. So the robot know your position is around 45 to 90 degree. Whether you off your robot and then you turn on back, then your sensor detect this position. So robot will know that your arm is at the position of 45 to 90 degree. So maybe your arm is positioned like this, 0 to 45. Or maybe 45 to 90, around that. Around that. So whatever you have power failure, or you turn off your robot, so once you on back your robot, the robot will know the current position of your robotic arm or your joint angle. Compared to this one, if you turn off your robot, so when you turn on back, so your, although the sensor is located this position, so the sensor didn't know the current position, what is the angle of your joint, so it didn't know because your reading is only high-low, you didn't know the position of your joint. Compared to this, you know that your position, for example, at 001 or maybe 011. 011 is here. 011. So you know that your position is at 90 to 135 degree. So you turn off your robot and you turn back, so robot will automatically know your position. So this we call absolute optical encoder. Any question on these two sensor? Ada tak? Boleh beza tak? Can you differentiate? Absolute and incremental. Boleh differentiate tak? Ni ya. Ya. Boleh ya. So this one is linear encoder. Normally you can see this in your printer. So in your printer, they use linear encoder. So because when you print it, your ink inject cartridge will move left and right kan. Left and right. Actually, your motor is following this strip encoder, linear encoder, similar to incremental encoder. So, what this sensor, this system required is only limit switch to reset the position. So that's why after you finish printing, so your machine will go to the reset position, reset switch. So to reset all the reading, position reading. So this is magnetic rotary encoder. This one you can find in a lot of DC motor now. They put magnetic encoder. You have north and south pole magnet, and you have sensor to measure the north and south pole. The sensor detect this small shift in the position north to south and south to north. there are many methods to detect the magnetic field change. So when you change the pole, so you start counting 1, 1, plus 1, plus 1, plus 1. So you start counting. But normally you have 2 sensors lah. So you can calculate also, you can detect also the direction of rotation. This one better you purchase. If you want to purchase the DC motor, better you purchase this one because the price is almost similar. Rather than you design your own encoder and put at the back of the motor, so it's not accurate. So better purchase the industrial standard encoder because it's more accurate. So this is how magnetic encoder work. So this is sensor. This is air gap between the magnet. So this is magnet disc. So this magnet disc they design that have different pole. So this changing the pole when the motor rotate, and then your pole will be changing at the front of sensor. So you can start counting the position of the rotation. And then this is potentiometer. Potentiometer. Okay. So potentiometer or variable resistor lah. So this is variable resistor. So you can find this sensor in servo motor. If you use a servo motor, the square black box servo motor. So the internal, the inside, the component inside the servo motor is this one, potentiometer or variable resistor. So this we call a wiper that changing your value of resistor. This is common, W or common. So if your wiper is turned to the left until contact A terminal, so your resistor between A and W is 0 ohm. 0 ohm because you don't have resistor value because your wiper already turned maximum until near to the pin A. So your resistor will be 0. But if you turn this wiper until terminal B, so your resistor value is maximum value. Is 1 kilo ohm. That means A to W is 1 kilo ohm. Because the current go through A, you need to turn the resistive material until find the wiper, because you turn until the maximum, until B, so then can go through W. So your resistor value will be maximum 1 kilo ohm. Same goes to B lah. So if you turn wiper until touch terminal B, so B to W 0 ohm. If you turn until terminal A, so your B to W is maximum 1 kilo ohm. So if you turn to the middle, to the center, so you will get A equal to 500 ohm and B equal to 500 ohm. With 1 kilo ohm resistor lah. So this is the schematic. So this is internal diagram. This is schematic. This is construction of the variable resistor outside view. This is something. This is the schematic drawing of variable resistor or potentiometer. So here is more easier to understand. So if you move this to A, so that means A to W is 0. If you move to the middle, so A to W is half. B to W is half. If you move until past the B, so B to W is 0, but A to W is maximum 1 kilo ohm. And then how we relate the mechanical, this is mechanical to electrical. So this is the formula how we relate. So how we relate the mechanical to the electrical formula. So if you want to find R1 value equal to theta. Theta, that means this, your wiper, where you rotate your wiper. And then the maximum theta or wiper can rotate. For example, if your variable resistor or potentiometer, you can rotate 180 degree. So your maximum is 180 degree. And then if you rotate at the middle, so you rotate at the middle, 90 degree. So this is 90. And then R total, what is the R total? For example, maybe this resistor is 1 kilo ohm. So you put 1000 here. So 190 divided by 180 is half 1 over 2 is half. And then multiply by 1000, for example. So you get R1 is 500 ohm. 500 ohm. R2, how you find R2? So this is theta maximum is 180 minus theta 90 divided by 180. So you got also half, multiply by 1000, you get 500. So this is how you relate 500 ohm equal to 90 degree. So if you turn your wiper to 90 degree, for example, so your reading is 500 ohm. And this the circuit that normally they use for potentiometer. They design using voltage divider circuit. Voltage divider. This is voltage divider. So this is pin W. So the output is pin W. And the bottom we put pin A and pin B. And then connect to the battery. So when you turn it, a wiper, so you will increase the resistor value. So if you rotate 90 degrees, then you will find out that your resistor will be 500 ohm, top and bottom. So the output voltage should be divided by 2. So this is the formula for voltage divider. So basic formula for voltage divider. So R1 divided by R1 plus R2 multiplied by V in. So you will get V out here. So if V out 10 volt, that means your output is 5 volt because you rotate your resistor at the middle, 90 degree. So your V out is 5 volt. If you don't have R1, so you can use this formula. So use a mechanical formula, theta divided by theta maximum multiplied by R total divided by R total multiplied by V in. So you will get also the same value, 5 volt. So this is one of the formula. The other one formula that normally they use in sensor is what Wheatstone bridge. So this is voltage divider. The other one, Wheatstone bridge. Later I show you how to use it. And the other sensor, so this is Before this is potential meter. This is position sensing. We call resolver, but this one is not famous for robotic arm. It's not famous because rotary electrical transformer used to measure degree of rotation. The output to analog signal correspond to shaft rotation, sine and cos. More reliable than encoder. More reliable the encoder, however, has lower resolution. Lower resolution, so that means it's not good for robotic arm, because robotic arm we need high resolution, need gearing to improve resolution so that it can be placed directly on top of joint. Okay. Tachometer, speedometer, this one normally we use at the car, so we can use at the car. We don't have robotic arm that can turn 360 degree. So normally robotic arm can turn about 270 degrees, something like that. So it's not suitable for robotic arm, but this is one of the analog to provide analog signal proportional to shaft velocity. So you want to measure shaft velocity. Position information could be derived from differentiation of velocity. Not very popular since differentiation could be introduced noise and time lagging. Okay, time lag. Okay. Last time I also didn't know how to define the position based on velocity. Then when I learn the mathematics, so I know, oh, that's why we learn integration and differential. So that formula we can convert back velocity to position. For example, if you have position sensor, you have position meter, and then you differentiate with time, so you will get velocity. If you can remember, if you have your robot, or maybe your robot will rotate 1 meter. 1 meter, that means distance, position. If you said 1 meter per second, that one is velocity. Okay. If you differentiate again with time, 1 meter per second square, that one is acceleration. How you get that value? By differential. So you differentiate by time, you get velocity. So you write your value meter per second. And then when you differentiate again by time, you get acceleration. How you write the answer? 1 meter per second square. So how you want to get back from velocity? 1 meter per second. How you want to get back your position? So you use integral. Kamelan, you use integral. When you integral with time, so you will get back your position 1 meter. So that means you can turn your wheel forward. If you measure based on time, so you can define your velocity, you can define your acceleration. If you want back your distance or position, you can use integral formula. Kamelan, integral formula. So you integrate your acceleration, you will get velocity. You integrate your velocity, you will get back your position. So after I learn, then I know, oh, we use integral and we use a differential to find velocity, and also we going to find position. So this speedometer, we can use speedometer to find out. For example, if you drive your car, 100 meter per hours. Kilometer per hours kan. 100 meter, 100 kilometer per hours. If you want to find what is the distance in half hour, so you need to integral lah. So you need to integrate in 0.5 hours. At glance we know lah, 100 is 1.5 half hour. Your distance is 50 kilometer lah. How to find 50 kilometer? You need to use integral. Integral from 0 to half hour, 100 kilometer per hour, so you will get 50 kilometer. So you get your distance. Okay, force sensor. Normally force sensor, they attach to the leg of the robot or they put at the finger of the robot. Any factor. So electrical based force sensor for foot, for robot using motor, very current to very force. Okay, so force sensor they use because they use a resistance inside the sensor. So the difference of resistance will give a different current value. So very force, very current. Because your resistance will be changed when your force is increased or decreased. So when your resistance change, that means your current also change. Pressure-based force sensor, normally for pneumatic and hydraulic actuator, very pressure to very force. So higher force, higher pressure, higher force. For lower pressure, lower force. Okay, force sensing, resistive-based force sensor. This example of force sensor is a strain gauge. One example of force sensor is strain gauge. So how the strain gauge work? So by friction. Changing of the length. For example, change in length over the original length. So because your strain gauge, you can bend. It's very flexible. You can bend tissues, stretch. So the resistor will be higher because your resistor become longer. See the concept there. Where's the example? Okay, this one. So this is strain gauge. If you compress, the resistor will decrease because your resistor line here become nearest. So your resistor become lower. If the arrange the thing, this one. If you stretch the sensor, that means the gap between the sensor become bigger. So when the gap become bigger, that means your resistor will be higher. So this is the concept of strain gauge. This is how we connect our strain gauge, and this is how we calculate our strain gauge. So it's still a voltage divider concept, but you have 2 points. You have, because you want to define the difference between point A and point B. For example, point A, point B. So we want to see the difference. So for example, VS, Vsauce, similar to voltage divider concept. So R2 divided by R2 plus R3. So R2 divided by R3. R2 plus R3 multiplied by Vs. So you will get this voltage. And the other one, R1 divided by R1 plus R4 multiplied by Vs, you get this output voltage. So you can minus whatever minus left to right or right to left. The important thing, you want to define the different volt, because normally we put sensor or strain gauge between these four sensor. So that strain gauge will change the resistor value. So when the resistor change, so we will get a different voltage between A and B. So we see the example here. For example here, you have a formula here. For example, this you have two strain gauge. Okay. This one. VO equal to VS, R3 divided by R2 plus R3, and then minus VS R4 divided by R1 plus R4. Okay, this one is you multiply. So you multiply, you get this one. But importantly, you remember this one. This is basic formula. This one is once you simplify, you get this one. So the important thing, you need to use this one. Because once you replace the value, so you get the answer directly, get the answer. So if you get, you don't have any different, V left minus V right or V right minus V left, you didn't get any different, you get 0 volt. 0 volt means that the bridge is balanced. Balanced, that means nothing has changed the strain gauge value. So nothing is pressing strain gauge value. Pressing up or pressing down. Stretch or bend. What term do you use? Bend or compress? Oh, sorry, compress. Stress or compress? Stretching. Tarik stretching. Stretch or compress. So if you compress, you have a lower resistance. If you stretch, so you have higher resistance. So if you have different resistor value here, so this group should have different voltage. This is like a control voltage. So because this is fixed resistor, you will get a fixed voltage here. So if you have changing resistance value at this triangle, so this output voltage here will have different, whether increase or decrease. So you will have a different output voltage here. So if you increase or decrease, so you minus with this voltage, or so you will get a different volt. So the different is the output for the bridge circuit. The different. So it's not different, that means nothing happened to the sensor. No force can be applied to the sensor. If you connect two sensors, so they put like this. So it turn down, so one sensor is stretching. If you turn like this, so the above sensor will be stretched and the bottom will be compressed. So this one, the value resistor will be high and the bottom value resistor will be lower. So you will get different value at this point. And this is fixed voltage value. So this is as a reference. So this value minus this value, this output minus this output. right output minus left output, you will get different voltage. That different will be used as information to our controller. This example of the a differential amplifier. So after we get an analog signal, this is analog output lah. So this analog output, so we will connect to for sensing, or 10 o'clock already. So we connect to differential amplifier. So the voltage from V1 and this voltage from V2. So if you don't want to increase your gain, so RF and R1 should be 1. So this is a gain for to set our gain of our signal for our signal. So V out equal to RF divided by R1. So this is gain. Multiply with V2 minus V1. Okay, V1 for example from this point, if you have one resist sensor here, so this is V1, this is V2. So this V1, this V2. So this point will have different because we have a different voltage output because we have sensor here. So we connect here, V1. V2 for the other two resistor control. So gain, if we don't want gain, so we just put maybe 100 ohm, 100 ohm. So 100 divided by 100, so gain equal to 1. So no gain, gain 1 lah. Gain equal to 1. So this one minus this one, we will get a different voltage. That we will use to send to the microcontroller to make a decision. Okay, so minus 1. So maybe you get a 0.01 volt. The result V2 minus V1, you get 0.01 volt. So 0.01 volt, maybe it's too small for microcontroller. Then you need to amplify. So amplify, maybe you make it RF bigger value. So maybe you need to make it bigger, 10 times bigger. So this one you put 1 kilo ohm, this one you put 100 ohm. So 1000 divided by 100, you get 10. So you increase 10. So this is how we increase the signal. This is the circuit of differential amplifier. Okay, this is before that we go to buffer. Sorry to inform. So we go to buffer circuit, output from the week10 bridge. We go to buffer. Buffer will prevent noise to enter this amplifier circuit, to prevent noise. This is amplifier. So if you want 5 volt, then you put the VDD equal to 5 volt. Then your output will be maximum 5 volt. So set your VDD 5 volt. If you normally we need 5 volt because we send to microcontroller. Microcontroller require 5 volt. So we didn't put 10 volt. If you put 10 volt, then you need to step down. You need to put another circuit, step down circuit to meet our microcontroller requirement. Okay. So this still analog. It's not digital yet. So the output here is still sine wave. Sine wave is not digital. Then we need another circuit we call ADC, analog to digital converter. So after maybe you increase your signal just now, you increase the signal 10 times. This one RF, this is R1. So 0.01 becomes 0.1 volt. So 0.1 volt. So go into DC. So VDD also you set 5 volt because you need to interface with microcontroller. So you use this 5 volt. So 0.1 volt. So you use this formula to generate digital output. So if you use 8-bit micro ADC, so the formula is 2 power of 8 minus 1. 2 power of 8 because you need to generate 8-bit digital. Divide by voltage reference voltage. So reference voltage is this one, VDD. So if you set 5 volt, you supply 5 volt, so V reference is 5 volt. Multiply by VA. VA is the input, V analog. So your analog input is 0.1 volt, so VA equals 0.1 volt. So you get your digital out. This example. So 256, 2 power 8 is 256 minus 1 multiplied by 3 volt, for example. Your signal input is 3 volt. Divide by 5 volt, your VDD. So you get 153. 153 digital out. So 153, use your calculator, convert to binary. So you get 1001, 1001. This is 8-bit binary. So this is 8-bit binary. So you have 8-bit. 1, 0, 0, 1, 1, 0, 0, 1. And then connect to your microcontroller. So you can connect to your microcontroller. So because maybe your microcontroller doesn't have ADC, so this is the technique how we convert analog signal to ADC, and then you will use 8-bit 8 port of microcontroller connect to this ADC. So you lost 8 port. If you have analog to digital pin, same as Arduino have analog to digital. So you just connect this pin directly to your Arduino microcontroller. So in Arduino microcontroller, they will convert to ADC. If you didn't have microcontroller ADC pin, so you need to connect this ADC IC. ADC we call converter. So you need to convert to ADC converter. Oh, I forgot to. Lupa lah. Lupa nak off. So banyak memori makan. Okay, so you have two calculation for sensor lah. So you need to focus on Western bridge and also voltage divider. Both are actually voltage divider. So you must understand the concept how to calculate the output voltage using sensor. Okay, this one for sensor. This is for sensor. So when you press it, so the capacitive base for sensor. So actually you press the matrix inside between plate lah. So that's why you can have a different value of capacitance for sensor. So between is dielectric, similar to capacitor concept lah. This is ultrasonic force sensor. So you have ultrasound inside the sensor. This is piezoelectric based force sensor. So this one, the basic fundamental, I hope has been taught by Prof. Abu Hassan. So I just focus on the calculation of sensor, and then how we connect the signal after we calculate the value of sensor, and then how we convert to ADC, how we how we prevent noise, how we amplify the signal, and then how we convert to ADC, to digital, and then connect to microcontroller. So this is complete how we we do a circuit, develop a circuit from sensor to microcontroller. Now it's 10:11 already, exceeding 11 minutes. So I hope we already cover all the sensor topic with Prof. Abu Hassan. I will share this after the class. So I share is, if I cannot share through WhatsApp, if the file bigger, then I will share the link to you all using WhatsApp group. So any question or not? Or everybody has floating in the sea?
Ada lagi, Doktor.
Ada. For this topic, so you need to focus on the calculation. On the calculation side, because you are open book exam, so I think it's not difficult because you have a reference, and also you have a guide lah. You have a guide. But make sure you understand how to calculate, and how you connect between sensor to the microcontroller, and how the circuit function. Okay, this one cover in OBE2. So OBE2 will be cover sensor and robot work cell. OBE1 will be DH. I still use a DH. I still ask a DH question in your OBE1. Not homogeneous transformation metric, because homogeneous is quite easy. Question. So I still ask DH method inside your OBE1, and three topic in OBE1. So OBE1 will be done in week 14. That's mean before study week. So you have about 2 or 3 weeks from now. Then OBE2 will be done week 1, maybe week 16. That means during your examination week 16. So your OBE1 will be around week 14. So there are no examination or study week. Study week maybe week 15 or week 16. So during study week, we don't have examination, but we have OBE1 before study week and OBE2 after study week. I do it early study exam week because I need time for marking, because my student is big now. It's about 100 plus, so I need time for marking. Okay, I will share the slide that after this. So this Monday, not Monday, next week, I plan to start a lab session. Maybe this weekend I will prepare Excel sheet. I will share Excel sheet into our WhatsApp group, and then you write your name inside the Excel sheet, your current group, because we have 4 slot or 4 session. I'm not sure we can combine or not. So I will put the Excel, so you write your group based on your current group. So easy for me to divide your small group, because we have 8 robot and some we have 4 robot. So I need to I try to arrange your small group inside each section, this class lab session. So I will share Excel later. So I share the link into our WhatsApp group. So you write your name inside the Excel. Okay, if no question, then we meet again next Wednesday as usual. Because this one I have a lot of meeting last Wednesday regarding final exam. So I cannot conduct the class. So I need to replace tonight. So next week we will run the class as usual. And also I plan to conduct the lab. So first lab next week. Okay. Assalamualaikum and good night. Boleh tidur.